you have questions about what we need to cover for our review session on Monday. And then I want to give you time to meet as a group and get your projects going. It seems that some of you guys aren't quite there yet, and you need to be. There is no extension on the program. It was due last Monday, but I told you I'll take it next Monday with no penalty. But after that, all bets are off. So it's really important you get this thing turned in on Monday. So I'm going to give you some time at the end of this hour to meet with your groups and kind of strategize and see what you've got to do to get this taken care of. You don't have time to react, but the time will evaporate. Okay,
like my
so
dreams.
the final. Obviously, the true-false questions I always ask about the architecture. So this will be SIC and the SIC-XE architecture. Assemblers. Macro processors. Linkers and loaders. So last semester on the final, I had some hand translation to assembler, but we have done that, so that's not going to be on your final. I think everybody is pretty much on board with that now, so I don't see a reason to. Okay, linkers and loaders. Blocks versus sections. That's one a lot of you missed. Make sure you know the difference. Compilers, what do they do? And compiler optimization techniques. This is an old final. Expressions. In assembly. That will be it. Okay. So these are the topics that we have to work with. All right, so I'm going to go through, this is an old final, so I'll ask you some of these questions so you get a sense. So at first, they're true or false. We've done this one, but anyway. If bits n equals 1 and I equals 1, this indicates that the addressing mode is neither indexed nor immediate.
True.
True.
False.
Is it one?
I'm going to read it again. In the SIC-XE architecture, if bits n equals 1 and I equals 1, this indicates that the addressing mode is neither indexed nor immediate.
Oh.
Kidding. That was the first question. You have to read these things. Okay, SIC-XE architecture. A modification record may be required for a format 3 instruction.
True.
Okay, give me an example then.
Repeat question.
Repeat. Okay, so make sure you read these.
I do.
A modification record may be required for a format 3 instruction.
False.
Never. Never. By its very definition. Format 3 has an immediate value, which is a hard-coded constant, or it has an offset. There's no address. There's no address. Only addresses need modifying. So that's a good true false question. For modification records, only addresses need modified. Is that true? Oh, you're in front of the camera. I'm in the way. True or false? I'm sorry, I lost my train of thought.
True.
What was my question?
I don't know.
Do addresses only need one?
Yes, thank you. Does anything need modification other than addresses? Not offsets, not immediate values, actual addresses. Is there anything else that needs modified?
No.
No. No, not at all. Okay. If the starting address for a program is 0, then all operands that are memory references require a modification record. I'm going to read it again. If the starting address is 0, all operands that are memory references require a modification record.
True.
Excuse me. I'm kind of in the way, aren't I? I'm being lazy today.
True.
You say all operands need modification?
So it starts at address 0, which means it's relocatable, right?
Yes.
Okay. All operands that are memory references require a modification record. True or false? All memory references require a modification record because it's relocatable. So, is this true or false?
False.
True.
Well, it can't be both, folks. All right, let me ask you a simple question.
False.
True.
False.
True.
It's true.
Is that set 3? Is alpha a memory reference?
Yes.
Does that require a modification record?
No.
Okay.
False.
So all operands that are memory references require a modification record, true or false?
False.
False. Is this tricky?
Yes.
Well, it's different because you're listening. When you have it in front of you and read it, you have all the information. So it's actually harder to answer the oral questions as opposed to, but anyway. All parts of an executable program must reside in contiguous memory. False. False, yes. Okay. So the flags are set to the following. Must the assembler print an error message, or is this okay? That's okay. NIXBPE. Error. No, it's fine.
It's fine.
No, it's fine. No, it's fine.
It's fine.
It's fine. It's indexed.
Indexed. Either.
Well, you have to be careful.
Oh, no,
You might
that's-
be
that's
saying to
false.
yourself, wait a minute.
That's false.
Wait a minute, it's immediate value, you can't have this and this. Well, it's true, you can't have 101, but what about 111?
It's only indexed.
This is neither immediate nor indirect, indexed. Base PCE. So that would look like this.
Yes.
Is that legal?
Yes.
Yes, it is. Okay. So, I don't design these to be tricky, but apparently some of them seem to be for you, but I got it. Format for instructions always have a 20-bit memory address.
False. Always has a
Format for instructions always have a 20-bit memory address.
True.
True.
False, true.
It's true.
False. I believe it's true.
False and true, oh gosh.
True.
So, I've had enough, I'm gonna start crying.
Oh, no, it's
True.
It's true.
No, it's not true.
It's
No,
false.
damn
No, it's not true.
I'm like over 8.
Is that legal? Can you have a immediate value larger than a 12-bit space? Can you do that? Can I put 50,000 in register A? Bro, what's the range of values with 12 bits? What's the range of values with 12 bits? Mine is 2048 up to 2047. Okay, can I do this? Yes. Sure I can. What do the bits look like? N, I, X, D, E, E. Immediate and extended. Is that legal? Sure it is. Y'all got real quiet in a hurry here. Understand I can't say LDA 50,000 because it won't fit in 12 bits. I could say LDA 500, but 5,000 is too big. So is the largest possible constant 20,047? I hope not. So yes, we can do that, but you have to do this. Which means that 20-bit field holds an immediate value instead of an address. Yes? So it can be up to 1 million. To the 20th. Let's see here. Dynamically linked program executables tend to be larger than static ones. It's the other way around. What is a statically linked program? What does that mean, a statically linked program?
Like entire library.
Yeah, there are no references to anything outside the current block, right? We did that linkage thing with program A, B, and C where you had to do the references between the 3 modules. There's just one module and everything's in it, including cout or printf or class string. It's all in one block, so of course it's bigger. Loaders place the contents of object executables in memory. Repeat the question?
Say again?
Yeah.
True or false? Loaders place the contents of the executable object file in memory. Okay, what does a loader do? What does a loader do? Loads the object file into memory. That's what a loader does. Yes, that's exactly what it is. Macro processors are not as flexible, or macros are not as flexible as subroutines because they do not accept parameters.
False.
Nobody better miss that. Linkers generally handle final program relocation details.
True.
The final program relocation details, are they handled by the linker or the loader?
Linker, isn't it?
Who handles the final relocation details? Linkers or loaders?
The loader?
What's the difference?
What's the difference? Linkers establish the references between program modules. so that you refer to something. For instance, we had prog ABC. You remember that from the test we just took. So there are references to PROGC and PROGA. Well, that symbol is not defined in PROGA. It's only defined in PROGC. So how do I refer to something that's in another module in this file? And that's what linkers do. They give you references that can point to external pieces of code. Right? Okay, that's what a linker does. What does a loader do? It puts it in memory. So who processes the modification records? The loader does, yes. Because the linker doesn't know what the address is going to end up being. It just has the instructions for how to process it. Okay. Dynamic linking is preferred over static linkings because it minimizes the size of the final executable. True. Macro invocations are handled at assembly time, but subroutine invocations are handled at runtime. Macro invocations are handled at assembly time, but subroutine invocations are handled at runtime. That's true. Macro processors work by creating a subroutine call in the program segment that invokes a macro. Macro processors work by creating a subroutine call in the program segment that invokes a macro.
That's true.
Garbage. Ridiculous. Nonsense. Where did I come up with that? Must have been drinking. Macros make subroutine calls, and that invokes a macro. It's like, wait, what's the non sequitur here? All of it is kind of nonsense, right? Okay. We're not going to do that. Okay, here's one for you. I like this one. It's kind of different. We haven't done this before. So I'm going to write it on the board here. Okay, there you go. When the program finishes its run, what is the value of the word in memory in gamma? In hex. The 6-digit hex value of gamma, what is it? Is this a hard question? I hope not. Shall we do it?
Yes.
All right, the first instruction, LDA alpha. That loads into register A the word in alpha. So far, so good? Okay. Sub beta. Right, because that's how the instruction works. Sub beta, it subtracts beta from register A. That's your accumulator. That's where you accumulate expressions that you're working on. store gamma. Okay, gamma. Gamma gets, and finally we have divided by 2.
A.
So the A register has A in it. 14 divided by 2 is A, right?
Yep.
Yes.
It's not 14, it's 20. Okay, what's in gamma? Well, the div didn't change it. It's 20, 1, 4. You follow that? Okay, good. Not terrible. I know we haven't talked a lot about, I mean, I didn't ask you to write a program in this assembler. That would have been an evil thing to do, probably. All right, some standard compiler optimization techniques. So I've got some here, and I'll probably ask you different ones since we're doing these. But the ones we talked about in class, you should know what they are. Loop unrolling. Loop unrolling. What's loop unrolling? Yes.
Where it expands a repetitive piece of code into continuous lines.
Into sequential code rather than loops and branches. Yes. Strength reduction. What's strength reduction?
Turns functions into
Cheaper
cheaper.
instruction.
Substitute an expensive instruction for a cheaper one. For instance, divide by 2. Instead of dividing by 2, we could right shift by 1 bit. Yes. Common sub-expression elimination. This is where the compiler identifies an expression that is executed repeatedly. And a good example of this would be a for loop. You have something like for int I equals 0, I less than array.length in parentheses, I plus plus. So how many times do you call the method length? How many times do you get array.length? Well, for every pass of the loop. So if the loop runs 1,000,000 times, then 1,000,000 times you call that subroutine. So you do it outside of the for loop so that you don't keep doing it over and over and over again. Dead code pruning. It's what it sounds like. Code that's not reachable can never happen. How could you do that?
Anything after the return statement.
Anything after a return statement. Yes. Well, a bare return statement. You, if condition X return 1, then it keeps going. But if you just have a return, also if you have an if else block and the else is impossible, that can be removed. So the example I think I gave you is a reasonable one. Well, what are you going to do in the else block? If x is greater than or equal to 0, else if x is less than 0, else. Well, is there anything other than x less than, greater than, or equal to 0? Is that possible? No, can't be. So whatever that code is, it'll never execute. Well, you could write that in the program. Hopefully the compiler would remove it. All right. In assembly language code, when two relative symbols appear in an expression, they must have opposite signs. Explains why this is so. When you have two relative expressions, they must have opposite signs.
Because, wait, I see explain why? Because that shows displacement of location. If you just had the same sign, it would just, you wouldn't be able to tell where exactly it is.
Right. Yes. So if you have to think about what this actually means, what's a relative expression? What does that mean, a relative expression?
Not a constant.
It's not a constant. Okay. A relative expression, a relative token, is one that will change if the program is loaded in a different place in memory. So for instance, we have the symbol, I don't know, list A. All right, what's the address of list A? Is it going to vary depending on where the program is loaded in memory? Yes. Alpha. Well, if you start at 0 and you have alpha in your program, alpha could be loaded in very different locations. That makes it relative. That makes it relative. Okay? But what about this? Does it matter where you load the program in memory? No, alpha is always 10, period. Okay, so a relative symbol, maybe we have beta word 20, gamma word 10. Okay, is beta relative or absolute? This is absolute. What's this? Relative. Because it can load in different locations depending on where the program is loaded. So it is a relative term. So the statement is, if you have two relative terms, they have to have opposite signs. Okay, so does this make sense? Gamma minus beta.
Mm-hmm.
Yes, it does. Well, that's a constant. What's gamma minus beta? 3. Because this is size word. So whatever this address is, this is 3 more. It's never going to change. It's always 3. Doesn't matter where it's loaded in memory. No, it doesn't. So it's always 3. So what you have now is two relative terms with opposite signs that resolve to a constant, an absolute term. What about this? Well, that's nonsense. Is that clear to everyone why this is nonsense? Let's make up an address here. Let's say that we have beta is at beta is at 1,000 and gamma is at 1,003. All right, gamma plus beta is 2,003. But what's that? You don't have anything at 2,003. Similarly, gamma, if you end up with a negative, here we have gamma plus beta. What if I have gamma minus beta? That's okay. Minus, well, I need another variable for label here. Data, word. So now you have a negative address. These cancel out, gamma minus beta, that gives you 3. And now you have minus data. Okay, that's nonsense. You can't have a negative address. So where relative symbols occur, they must occur in pairs. And if you have one left over, the one that's left over has to be positive after you've paired them. Is this clear to everybody? So if you have relative terms, alpha plus beta, is that okay? No. Alpha plus beta minus gamma. Is that okay?
Yes.
Yes, because these will pair, or gamma and alpha, doesn't matter. You got a plus and a minus, take them out. You got a plus left, you're good. If you have a minus left, it's no good. Because it's going to give you a ridiculous address. Either a negative address or one way out of range. Okay. C++, I'm not going to ask you that. And finally, I have a question for your teams. I'll tell you what the questions are. What percentage of the work on the programming assignments did you do? What percentage of the work did your team members do? Who on your team did most of the work? What problems, if any, did you have with the team? So this is confidential. No one's going to see this but me, but I want you to tell me if your teams did not function correctly, if there were issues. It has happened. I know there were some issues with some of the teams. There are people in this class, essentially who are not here today, that did nothing. And so I want you to go ahead and tell me, and I will not reveal what you have told me to anyone. Moreover, I will not hurt anybody. So if Joe Blow, that's kind of blown the class off and not done any real work, and his team members say, well, Joe didn't do anything to help, fine. If his percentage is 75%, he gets his C. I'm not going to lower anybody's grade based on what you tell me. If, however, Joe's average is 75, and everybody says Joe did most of the work on the programs. He was always there. Our programs were great, and he did most of the work. Then instead of a C, I can give him a B. So I will not lower anyone's grade, but I will possibly, depending on how things look, raise somebody's grade. So it's important that you tell me truthfully what happened with the teams. Part of it, too, is it's a learning exercise for me. I think one of the problems we had was that some of the teams were too small. In semesters past, I had teams of size 4 and 5. That seemed not to work because that enabled some layabouts not to do anything, and with a team of 5 people, then somebody could just kick back and let the others do it and not worry too much, and the teams were able to produce the code. But it let certain people not do any work. Well, I thought I'll make the team smaller, and that will force people to be more actively engaged. And it seems to me, my impression is that's not really true. The layabouts are the layabouts. And whether the teams are 5 or 3, they're still going to be layabouts that don't do anything. And frankly, even if you have someone on your team that's not the strongest programmer, that can still participate and contribute. Testing is something that nobody wants to do, but everybody can do. And so, if there were issues, I'd like to know what they were. And again, like I said, I'm not going to hurt anybody. But for people that did lots of extra work or did, more than their fair share of the programming, then I will consider raising the grade. So it's always troublesome when I read these, and I've got this separated team here, and I've got this team, and there are 4 people on the team, and person A says, I did 80% of the work, and person B says, I did 90% of the work. And somehow that doesn't add up to 100, and there's 2 more people to consider. So please give me a reasonable assessment on your part on how this played out, and I will take it from there, and I will never tell anybody what you told me. So, all right. Questions, anyone? So I'm going to make up some questions. I'm going to go dig out old final exams, and on Monday we'll kind of do what we did a little bit here. This is to give you a flavor of what to expect, and go through and work some problems and try to prep you for this final exam. There's a lot of points involved, and I would like the grades to be good. So, yes.
Is it worth more than all of them?
I forgot. I'm thinking it's like 200 or 250 points.
It's 200.
Is it 200 points?
Because it's 50% of our grade, first two are 1.
Then that would make it 200 points, wouldn't it? All right, so that's 2-letter grades. So obviously that matters. I mean, if you get a 0 on it, it will drop you 2-letter grades. Nobody's going to get a 0. I shouldn't say that. My 237 class. I have to tell you, I've never seen this before. I've been teaching not quite 20 years. I've done it quite a while. And I had a student this time take midterm 3 in my 237 class, and he answered most of the questions. A couple of them he didn't. But he got 0 out of 150 on the midterm. I have never seen that before. It's like, why? What are we doing here?
Draw pictures.
I don't know how it happens. I don't want to make fun. Something's going on. Obviously, he doesn't want to be in school. But why, after all this time, show up and take a test? Didn't make any sense. Anyway, beside the point. So if you did get a 0, that of course would cut your grade. But nobody's going to do that, right? So we'll be well prepared and end the semester on a high note. That's the goal. All right, I'm going to stop here. I want you to take the time now to get together with your group and strategize and make sure you know